Good morning, friends, and welcome to the 64th episode of Tech Talk from Tech Forum. Tech Forum is a group of like minded technocrats, and we meet every month twice and discuss on different topics. Most of the lectures are online, and there are few offline lectures at Institution of Engineers. Today's lecture is on rubber technology and its applications, and we have Mr. Mohan Deshpande with us today. Mr. Mohan Deshpande, at present working as a consultant with SNPP Seals Private Limited. He started his career with NCL. He is MSc in Polymer Chemistry and LPRI from PRI, London. 8 years at NCL as a scientist in polymer chemistry, 38 years in various companies, faculty member at ARAI Pune chapter. So he is having a wide experience in industry as well as academia, and he is well known in rubber industry as Rubber Deshpande. You know, natural rubber is a raw material used in production of many products. Rather, life without rubber is you can't imagine. It's utilized in medical devices, surgical devices, aircraft, car, you name, you will find application of rubber. Rubbers are classified as polymers having elastic properties, and hence they are also called as elastomers. Rubbers are classified based on their heat resistance properties and persistence to various types of oils, which are used as a medium in service several machines. In our first lecture, we shall discuss on types of rubbers, product name from these rubbers by molding process, critical role of rubber products for various applications. So this is going to be a quite interesting talk. We have kept 20 minutes for question and answer. Mr. Deshpande will speak for 40 minutes, and then it will be followed by question and answer. So with this little introduction, I will request Mr. Deshpande to start his presentation. Over to Mr. Mohan Deshpande, rubber technologist.
Thank you, Vilas, and good morning to everybody. As Vilas explained in short, the importance of rubber and everything. So now I will move to the first slide, which will explain about. This will give some basic information about rubber. Just now he touched upon the subject. Rubbers are polymers, or they are also called as micromolecule. In Greek, poly means many, and mer means unit. So when many units come together, or many molecules join together by a bond called a covalent bonds in chemically, they form a long or huge chains, and these chains are later on converted into a three-dimensional structure, and which are called as rubber. Rubbers are basically classified as elastomer. Now, what is elastomer? All of you may be knowing. When you stretch any rubber, for example, the rubber band, when you stretch it and release the pressure, again they come back to its original position. So this unique property of rubber is very, very important. And the same property you can't find in plastic. So that is the main difference between the elastomer and plastic. So therefore, rubbers are classified as elastomer. Rubbers also have a property called as viscoelastic. That means they have viscosity also and elastic in nature. Now, there are various types of rubber which are based on their heat and oil resistance, they're classified. Resins, plastic are also included in polymer. So now we'll just go through the types of rubber, their symbol, and which are the monomers. As I told you in the beginning, polymer means many units joining together, but these are called as monomer units. They are also classified as copolymers or homopolymers. For example, when I discuss about natural rubber, the symbol is Na, and the main unit comprising of this polymer is called as isoprene. Isoprene is a chemical unit. When many units join together, they are called as polyisoprene. So what we say natural rubber is nothing but polyisoprene. And natural rubber, as the name itself suggests, it is obtained from a tree in the form of a milky white substance called as the latex. And that latex later on by some processes converted into a dry rubber. So latex in the form is also useful, and latex in the dry rubber, which is called as the natural dry rubber, is also useful to manufacture many of the important products, for example, tires and etc. Now, since natural rubber is a natural thing, there are other man-made polymer or man-made rubber which are called as synthetic rubber. Now, the following list will give you about the synthetic rubber. For example, styrene butyl rubber, which is called as SBR. Here, the monomer units are styrene and butadiene. Styrene is again an organic compound, whereas butadiene is an aliphatic butadiene. Then neoprene is the third rubber, which is called as CR, and its monomer is fluoroprene. And neoprene is nothing but polychloroprene. That means when many units of fluoroprene join together, it forms polychloroprene. Only in case of natural rubber, where we call it as polyisoprene, the viscosity, or in other terms, the molecular weight, cannot be controlled because it is a naturally occurring polymer. Whereas in the synthetic kind of rubber, you can control the molecular weight during a process called as polymerization. So synthetic rubber will have a defined molecular weight, whereas the natural rubber doesn't have any defined molecular weight. The molecular weight is a very, very critical and important thing, which in rubber technology, it is explained as Muni viscosity, or in other terms, it is called as viscosity. So the third rubber, the fourth rubber is polybutadiene rubber. It is called as PBR, where it is the butadiene is the monomer and the polymer is polybutadiene. Then the fifth rubber is the nitrile rubber, designated as NBR. Here the monomers are eclectonitrile and butadiene rubber. The sixth one will be EPDM, ethylene propylene diene monomer. It is designated as EPDM and ethylene propylene, and there is some amount of diene is added. So there are three types of monomer units in this. Now next slide will also give you seventh is silicone rubber, which is symbol is Si, and the monomer unit is siloxane. Then comes Viton. Viton is nothing but fluorocarbon rubber. That means fluorine and carbon. Whereas the other rubbers, what you have seen is carbon and hydrogen. Here the hydrogen is replaced by fluorine. So therefore, there will be a lot of changes in the important properties, which we'll see in the following slide. So FKM is the symbol for Viton. Viton is a trade name which was invented by DuPont company, USA, and fluorocarbon is the chemical composition. So here the vinylidene, fluoride, and hexafluoropropylene, these are the monomers used. Next is the polyurethanes, which is designated as AU. Here the isocyanate and alcohol are the monomers. Then comes the butyl rubber. Butyl rubber is designated as IIR, and the monomers are isobutylene and isoprene. Then the polysulfide, which is designated as PSR. Here the ethylene dichloride and sodium tetrasulfide, they reacted to form a rubber called as polysulfide. Next is a polyacrylic rubber, which is designated as the ECM. Here the ethyl acrylate and butyl acrylate are the monomers for carrying out polymerization process. Then the last one is hypalon, which is called as the chlorosulfonated rubber, which is called as polyethylene sulfide. When you chlorosulfonate polyethylene, you get chlorosulfonated polyethylene. See, my idea of giving all these brief is, before jumping into the actual uses of the rubber, we should know what are the different types of rubber as a basic minimum understanding. Then how the rubbers are processed, what is the process flow chart for manufacturing rubber products. As in Indian industry, the process flow chart is followed. Similarly, in rubber industry also, you can see the incoming raw materials which are inspected and then approved. As far as rubber industry is concerned, there are a variety of rubber, variety of chemical. So all the rubbers and chemicals as per the quality plan, they will be inspected and approved. And once it is approved, then the whatever formula is there, as per that formula, you have to weigh as per the recipe. And after weighing, the next process is the mixing process, which I will tell you in the detail in the next slide. After the mixing, the mix, or which we also called as a rubber compound, is tested, because without testing it cannot go for production. There are various types of tests, which again I will brief you afterwards. And then after the approval, then the real process starts, which is called as the blanking process. That means before you go for the molding, the rubber need to be in the different form, required format, which is called as the blanking process. And once the blanking is carried out, then the actual rubber manufacturing process consists of injection molding, compression molding, or transfer molding, depending on the type of product and the process required. Once the injection or compression molding process is over, your rubber products will be ready. Then depending on the requirement, you have to go for next process, post curing if required, because in injection molding, the first curing or the initial curing takes place for a very short time. So all the optimum properties of the products are not developed during this stage. Therefore, post curing is required, where in a big oven, all the products are stored at required temperature and required time. And after that, you can open and cool the product, where all the optimum properties in the rubber would have been developed, and you can use the rubber product. After this, there will be finishing process, which you have to do by manual or by machine also. Once the products are ready, they need to be inspected in terms of dimensioning inspection and usual inspection, because in most of the critical components, the usual defects are not acceptable. For example, in the area where I have been working, brake seal, which I used in automobile industry, are very, very critical. Though it is dimensionally okay, even a small pinhole or air trap or any foreign matter would create a lot of problem in applying the brake system. So therefore, inspection, both the dimension and usual are critical. Once inspection and dimensional usual are approved, then it goes for washing and drying, and afterwards counting and dispatch to the customer. Now, what are the commercial rubbers and compounding materials? When you consider rubbers alone, they are of no use at all. So if you want to make use of the rubber, various ingredients need to be incorporated into the dry rubber by mixing in various types of mixers. The mixed product is called as carbon master batches. Generally, in any rubber industry, the mixing process is in two stages. One is the carbon master batches, which generally they call it as a CMB, where the rubber and all other what I will below are mixed, and in the phase only additives or the cement or vulcanizing agent are then added into again in a small mixer and then mixed. It is called as the final mixed batch. That means once you have a FMB, then you have to use it in a limited time of period, depending on the course time and other properties. It is called as the shelf life of the rubber. Maybe 8 days, 10 days, or 15 days, depending on your recipe and the type of the polymer. Now, master batches are then converted to final batch by further addition of, that's what I explained to you, is known as compounding. Ingredients and their functions For the benefit of those who do not know anything about this, I am just briefing here. What are the ingredients, and this ingredient functions as what? For example, when you take any dry rubber, or the formula could be blend of one or two more rubbers also, which functions as a base polymer. Then comes the carbon black or silica. These act as a reinforcing material. As I told you, rubbers alone cannot be used because they don't have that strength. So by adding reinforcing material, rubber will develop hardness, stiffness, strength, and abrasion, which are ultimately responsible for the product to function or product to perform. Then different types of calcium, clays, calcium carbonate, etc. are used, but these are non-reinforcing filler. In some industries, they use for reducing the compound cost. But in some of the compound, you cannot use the non-reinforcing filler because they will not be able to develop the required properties. Then is the zinc oxide, which acts as an activator for boosting vulcanization process or curing process. It also improves heat resistance property. Then is stearic acid. Stearic acid is used as dispersing agent. That means when you are mixing a compound, the dispersion plays a very, very important role. Dispersion of carbon black into the rubber to get a homogeneous mixture. So it acts as a dispersing agent. Plus, it also acts as an accelerator for activator. You have seen zinc oxide is an activator. So this stearic acid will accelerate the activators also. Then it also improves mold flow and aids in releasing the mold. When you want to release the products from the mold, so it eases out the mold product release from the mold. Then there are certain agents used as peptizer. This is basically used for natural rubber. As I told you in the beginning, natural rubber is a natural rubber and it doesn't have any control on the molecular weight. So when the molecular weight of the rubber is quite high, and when you put such rubber in the mixing mill, it is very difficult to mix it because of the high molecular weight, it doesn't soften immediately. So peptizers are those chemicals, when you add in a small amount, 3.3 to 0.4, they break down the polymer. That means the molecular weight is reduced, viscosity is reduced, and it improves it helps in adding the carbon black and other ingredients. Next is you have to use various types of oil, softeners, and plasticizers to make mixing and extrusion easier. So whatever just now I have discussed is done during the carbon black master batches, or sometimes it is called as a mix A also. Now once this mix A is mixed, there are certain tests you need to carry out. One is the specificity and another is the viscosity. Because the control of viscosity and specificity is important before you really go for the next step or FMB or mix B. In second step, various vulcanizing agents are added, which are basically sulfur or sulfur donor. And in certain polymers like peroxide and other thing, for EPDM and other thing, you can use peroxides as vulcanizing agent. And their main function is cross-linking of rubber chains, because rubber chains are already polymers. So when it is further cross-linked, either with sulfur or with peroxide, you can get a real useful product, which are three-dimensional in structure. And it is this structure which impart to the product more tensile strength, elasticity, and resistance to abrasion. So this is the function of the vulcanizing agent. Now, if you use only vulcanizing agent, the vulcanizing speed will be very slow. So in practical, when you do any product manufacturing, you need to be cost conscious. So in order to expedite this vulcanization process, there are accelerators added in a certain amount, which I will be showing you in the next slide. So accelerators are basically classified under thiazole, sulfonamide, dithiocarbamate, and thiourea. These are various types of accelerators, which are also called as primary accelerator, secondary accelerator. Their basic function is to accelerate curing process. Unless you add these accelerators, your molding process not going to be economical. Then there are certain protective materials. As you know, rubbers are prone to oxidation. They can be affected by ozone, exposing to ozone for a long time. So therefore, to protect rubber products for a longer time, there are certain chemicals like phenylene diamine and quinoline are added, and they function basically as antioxidant and anti-ozonant, and they also retard flex cracking. Flex cracking is another properties of the rubber product. They do crack during the operation, during the service operation. So in order to get a good flex cracking resistance, these chemicals are added. Okay, now let us go to the rubber recipe or rubber formulation. The compounder's prime responsibility. That means when you say a compounder, for example, I am a compounder in my company, you have to have a lot of knowledge about whatever I just now explained about the rubber, about the formulation, about the end use, about the customer specification. Then only it is possible. Apart from that, you should know also at what cost the product needs to be sold. And based on that, you have to formulate a compound. Basically, as I told you in the beginning, the compound contains base as a rubber, and the recipe what I have given in general it is based on parts per 100 of rubber. That means when you want to make any composition, so 100 is fixed. 100 could be parts by weight or whatever it is. The zinc oxide is generally added in this ratio 5 to 10. Uric acid about 1 to 1.5. Antioxidants 1 to 1.5. Anti-ozonants I am just given the rough recipe. 1 to 1, 2.5. Peptides are about 0.5 to 1. Then pre-vulcanized inhibitor. This is again a chemical which added in a very small amount, because in rubber industry, the major problem is the scorching of the rubber compound. So this actually prohibits the pre-scorching of rubber or pre-vulcanization of rubber. It is added in a very small part, 0.3 to 0.8. Then carbon black, as I told you, is the main reinforcing material. Depending on the hardness required, you can add 20 to 90% also. Then when you make this rubber, it becomes totally dry. And incorporating of any filler like carbon or silica is very difficult unless you use a small amount of processing oil. So processing oil, depending on the nature of the product, it can be totally dry also, or it can add 5 to 10 parts also. So till now, what I explained to you is again carbon master batch or mix A. Then once the mix A is ready, it is basically in the form of a sheet form. Then the sheets are cooled and checked, as I told you, specificity and viscosity check. And the storage life of these master batches is quite high. You can keep it even for 6 months also, nothing will happen. And once your recipe is decided, then you can go for FMB chemical. FMB means, I told you very clearly, final mixed batch, wherein we will be adding only 2 chemicals. One is the vulcanizing agent and second is the accelerators. Vulcanizing agent maybe from 5 to 2.5 and accelerators are 0.3 to 1.5 parts per 100 of rubber. So once your recipe is ready, you have all these compound ingredient. Now you have to go for the mixing, compound mixing. Again, this process is a very important process, because after accurately weighing all ingredients now need to be mixed homogeneously. Because if the compound is not homogeneous, your product quality may differ. So therefore, mixing or getting a homogeneous mix is very important. It is generally done in a mixer, which are also called as Banbury, or in open mill, 2-roll mixing mill. In Banbury, the mixing process is totally under closed condition. There is a big chamber inside, and it is totally computerized. All the weighing and other thing is computerized. But this facility is very, very costly, Banbury and other things. But there are now companies who are really doing service for us. For example, we are getting from a company called in Chennai. We don't mix a single CMB in our company. We give our recipe to them and all the chemicals, including the manufacturer. We give the process, they establish the process, PPAP is carried out, and then we bring the ready-made CMB mix to our company, and then we mix CMB, FMB in our own company. The same CMB can also be mixed by using two-roll mixing mill, which is again an open mixing mill. For your benefit, I have shown some drawing here, some photos. Then while preparing FMB, proper cooling of rollers is essential to avoid scorching of compound. This mixing is basically carried out in a big mixer. There are two big rollers, stainless steel roller, and they are rotating at a different speed. Speed cannot be same. So the speed is different. And when you have a gap between the two roller, you put your rubber or polymer inside. Because of the very high shear and mechanical shearing, the rubber starts becoming a little bit hotter. That means you are slowly reducing the molecular weight and then go on adding all the chemicals. For this also a lot of automation is required. The sequence of mixing and the time of mixing, what is the temperature, everything is very important. It is controlled through totally through a DR, that means through a PDIR or whatever you can call in your. You can see these photos here. This one is the controlling unit. It will control the temperature. Then there is a separate chiller to control the temperature of the roller. Because if the roller temperature goes out of control, then the rubber may scorch. Okay. Now after the mix is over, you can cool the compound, entire compound, and dry it. Cool it and then take it out in the form of sheet. And then comes important activity, the compound quality. Before rubber compound is taken for production of part, it should be checked and approved by the concerned department, that is quality control. And the test on compound quality are as follows. One is the specificity, which is now direct specificity values are required. Specificity is important because it is always controlled in plus minus 0.2. Specificity indicates two important things. One is whether your weighing is correct. If your weighing is accurate, then you will get the specificity in the desired value. If the specificity is not as per the standard or established norm, then the compound will be rejected. Then the next property is the Mooney viscosity and Mooney scorch time. This is also again important property from the processing point of view. Then there is third property which is called as the rheograph. Rheograph is also very important. Most of the industries do not have, only organized industry, because the cost of rheograph today is around 40 to 50 lakhs of rupees. But this gives them a very good idea about the quality of the compound. This is basically nothing but you are monitoring the viscosity rise or how the cross-linking will take place at a particular temperature. It is nothing but getting the graph of torque against time at a particular temperature. For example, if I have a mix and my processing temperature is say 170 degrees centigrade. So what I will do is, this is the rheometer, which I will set the rheometer at 170 degrees centigrade. And then a small 5 gram sample is put in between this. There is a rotor here. Put this here and close it. Under this thing, there will be shearing. Same time, you will get a rheograph. And the rheograph will tell you what is the initial viscosity of the rubber, what is the safety of the rubber, which we call it as the scorch time. And then what will be the maximum torque it can attain, and what will be the TC90. It is called as TC90. TC90 means time taken for developing 90% of the optimum property in the rubber industry. So that time is taken now for processing of your rubber. For example, if you have got a mold at 170, my TC90, say, let us say 2 minutes. That means when you develop a product, you have to give minimum 2 minutes curing time for the vulcanization process. Then next in the hardness degree. Hardness is another critical parameter in rubber industry. Hardness can be sure A, or it is also called as IRGD. IRGD is International Rubber Hardness Degree. Some of the critical parts like brake parts, brake seal for example, you have to check hardness in IRGD. That is, you can see this photo indicates the checking of hardness. This is totally operator, de-skilled operator. You can just put the piece and there is a reading here. It reads out what is the hardness, even in fraction, say for example 70.2 or 70.3, whatever it is. Here the advantage is even the rubber is very thickness is very small also, you can check IRGD. Where for shore and other things, you require about 6 millimeter button for checking the shore rate. Now the difference between shore and IRGD is not much. It may be about 1 or 2 degrees more or less. Then tensile strength. You can see the tensile strength of the rubber is another critical parameter which need to be tested. Because when you develop any rubber compound, these properties are very important. Unless all these properties are checked and verified that this compound will have minimum of these properties, the compound will not be sent for production. This will be rejected in the laboratory only. Then it may be either reprocessed or reworked, and then it is used for this. So tensile strength and elongation at break are also checked on this tensile strength machine. In addition to above tests, the following properties are also checked as per customer material standard. Now in companies like ours, where the customers are giving us the drawing, and the drawing will, apart from the detail of the product, will also mention what is the material to be used, what properties they are expecting. So these properties are also checked in the beginning. When you develop a compound, you have to see that the compound what you are preparing and which will be used for production should be okay for the properties apart from what I have explained to you. The most important property is the compression set, then heat aging. That means the product is subjected to various heat conditions in the service, maybe 100 degrees centigrade, 120, 150, sometimes 200 or 250 degrees centigrade. And then some medium is used for oil aging, for example, oil seal. They are always in contact with the oil. For example, brake seal, they are contact with brake fluid. So fluid aging or oil aging is carried out. Similarly, cold resistance. That means up to what sub-zero temperature the rubber can be serviced or servicing temperature. Abrasion resistance. This is also important. Rubber should not be too easily abraded, otherwise the life will be less. Similarly, cracking. This is also important characteristic. Rebound resilience. It has to have certain amount of rebound. So rebound resilience is tested. Bonding test. This particular test is important for rubber to metal or rubber to textile products, because the bond has to be very strong. If bond is loose, then there is a separation of rubber metal or rubber texture, where the product will have a premature failure. Then the most important character is ozone resistance. Ozone resistance is also important because during even an automobile, the engine will be producing continuous ozone. So the rubber products in the bonnet will get affected by the ozone. So ozone resistance chemicals are added, as I told you in the beginning. So therefore, if you see most of the rubbers used in automobile industry are EPDM. EPDM has got outstanding ozone and weather resistance. Even the car what you are using, door seal and other thing made of EPDM, which we'll discuss in the subsequent slides. Now, as per the process flow, we have come up to the compound approval. Now, in briefly, we'll see how the rubber products are manufactured. The following processes are employed for manufacturing of rubber product. One process is called as the injection molding process. Second is the compression molding process. Third is the transfer molding process. You can see in the photo, this is our German make injection molding machine. Then this is Taiwan compression molding machine with vacuum. Then in the same thing, you can have a transfer molding. Okay, then this is the blanking process. Then D will be, there are certain products you cannot manufacture by using either injection, compression or transfer. For example, if you want to make hoses or some tubes, so you have to go for a process called as extrusion. You have to extrude the rubber in the form of tube, and then those tubes are vulcanized in the autoclave. That is called as the steam vulcanization. So either it can be electrical vulcanization or steam vulcanization. Both processes are possible. Injection molding machines are very expensive, but are highly productive due to shorter cycle times, and consistent quality is ensured. Modes for injection molding are also quite expensive because they are integrated mode. Because certain components they have to manufacture by injection molding. For example, the unit where I am working, we are manufacturing, for example, brake component. Brake components are very, very small, tiny components, and the quality need to be ensured because you cannot afford have a single component or single brake failure in the field. So why I am insisting on this injection molding machine is here everything is preset. What you see this screen, I have to enter and keep it forever. So no changes will be made by the operator or anybody. And the process, what this follows, is totally automatic. You don't have to do anything. The job of the operator is just remove pad and keep it. So basically, injection molding is the blank or rubber, what I explained to you, is fed into this extruder. The rubber will get plasticized and then it will enter into the injection unit, and the rubber and the plasticized rubber will be injected at a very high speed in the mold, and then the mold will get closed, and after the curing time, the mold will get opened. You just remove. So here the accuracy level is very high. The mold temperature can be controlled within ±1 degree centigrade, and operator cannot play with such type of processes. Compression molding is the most simplest form of molding process for rubber product. It doesn't require much complicated molds also. Only the problem is it requires very high cycle time, maybe of the order of 7 to 8 minutes, depending on the rubber product thickness. Then the third process is called as the transfer molding process. This process is largely employed for, say, metal to rubber product. So there is a pot called as the transfer pot, for rubber is placed in that, and then it is transferred into the main cavity. Here you end up losing some wastage because cured rubber product will be in the pot. But there is no other way for rubber to metal molded component. This is the generally accepted in industry. Product called as the tubing, hoses and other things, as I told you. You have to braided hoses, you have to braid and then subsequently they are cured in autoclave. Now, once the rubber product is ready, what about the quality? All rubber products to meet customer requirement. As all of you know, meeting customer requirement is very, very important. So customer generally in his drawing gives us all the details, like we need to do layout inspection, then user inspection to ensure, as I told you, products should be free from defect, pinholes, scratches, whatever, trier, underpine, foreign particles. Then certain customers specify what should be the surface finish value. This is also important. For example, in the product called as the disc brake seals, nowadays the disc brake seals are used. So disc brake seal finish is very, very important, that they mention what is the RA value to be maintained. Then the flash levels are given in the drawing. What is the flash level at the parting line? Then what are the heat aging and oil aging on parts required, what should be the change in the volume, what should be the change in the hardness degree, or weight loss, everything is given. These are all physical changes I can say, or physical requirement. Most important is the six engineering performance test, like durability. When I say durability, durability means actual simulating the condition and performing the engineering test, like steel friction test, or what is the durability, high temperature durability, low temperature durability. So customers generally carry out this. Sometimes we also carry out and give our report to them. These are the inspection tables you can see. These are the inspection tables where every product is tested, checked under microscopic lens, and then it is then only it goes for the packing. The laboratory, all facilities you have to check all the properties, heat aging, oil aging. This is the oven where you carry out the oil aging for products. Till now, we have discussed everything about basic rubber, what is the compounding, what is master batch, how they are made. Now we'll go to next slide, where we'll see some of the applications of the rubber process. As Viraji in the beginning has told, there is no area where rubber is not having its presence. So in areas like healthcare, I'll just run through automobile and aircraft, construction industry, infrastructure, electrical, electronic, chemical industries, mining industries, printing, paper industry, textile industry, shipping industry, and various other uses of each type of rubber. So we can see it is covering almost all industries, and it is estimated that around more than $400 billion is the total business, including the polymer manufacturer, rubber chemical manufacturer, is the revenue, because basically its application in the what area. Next slide will give a brief idea about rubber, specific usages. For example, when you say natural rubber, generally natural rubber alone is not used in most of the application. It is always used in combination with either SBR or polybutadiene. That means styrene butadiene rubber or in NR. Mostly in a composition called as 80-20 or 60-20-20, like that. The uses what I have given here is for tires, cars, buses, even aeroplane tires are also made in rubber. Then gloves, footwear you can use, gum boots and all that may are made from natural rubber. Anti-vibration mountings, then coupling, then some brake components also can be made from natural rubber. But the limitation of natural rubber and SBR is the temperature, what I explained to you. You cannot use more than up to 70 in case of natural rubber. And SBR is properly compounded, you can use up to 100 degrees centigrade. Next rubber is the neoprene. Neoprene is nothing but polychloroprene. You can use in wire and cable, belts, cover, tubes for house gasket. Then the LPG tubing. That means what we are using in our gas today for connecting gas meter to this thing is the LPG tubing. There it is purely made of neoprene, because it is self-extinguishing. Even if it catches fire, it immediately goes off. So therefore, it can be used in the LPG tubing. Then certain fire door, then in certain bridge bearing also it is used. Next polymer is the nitrile rubber. Nitrile rubber, as I told you, it is nothing but acrylonitrile polybutadiene rubber. It is used in various adhesives, used for structural adhesives, automatic transmission, seal, fuel, some spelling mistake. It is fuel line and hoses. It is used in printing rollers, industrial gloves, flexible coupling, conveyor belt, brake lining, drive wheel, then fuel pump diaphragm, carburetor float, hydraulic hoses to transport many of the mineral oils, then abrasive wheels. These are some of the applications. Polymetallurgy, as I told you, it is always in combination with NR and SBR, basically for tire tread and tire sidewall and some of the shoe sole applications. Next is the EPDM. EPDM, as I told, EPDM is ethylene propylene diene monomer. Electrical insulation, jacketing, automotive seals. All the brake seals what we are making today is from EPDM. All the required for all automotive car. Window seals, radiator hoses, what you see in your car, heater hoses, even then washing machine, door seals, brake parts. EPDM, if properly formulated, it can go up to 120 or 150 up to intermittent temperature. Next is the silicon rubber. In most of the aerodynamic seals are made in silicon rubber. There are dust seals, wire and cable, automotive seals in automotive transmission system, spark plug boots, etc. Then the seventh rubber, what we are discussing is Viton, which I told you, fluorocarbon rubber. Silicon can go up to 200 degrees centigrade. It can withstand up to 200 degrees centigrade. And its low temperature resistance is up to 50 degrees centigrade. Viton, that is fluorocarbon rubber, are again used for, these are all called as specialty polymers or specialty rubber, where the cost is also very high, but at the same time, it is worth using for temperature more than 250 degrees centigrade. It can withstand 270, 280. It is again used in aeronautical industry for making o-ring, gasket, fuel hoses, joint, automotive steel, aerospace steel, pumps and valves, oil and gas industry. Then the next one is the polyurethane. Polyurethane basically for making the foams. What you see in your fridge or any this thing, the polyurethane foams are used. Even the bedding or furniture or seating, the foams are used, made up of polyurethane basically because of its excellent abrasion resistance. It has got a very good insulating property, particularly the low density polyurethane. That means where the density is brought down up to 0.4 by using some blowing agent or foaming agent, and therefore it is used as a insulating material. It also used in footwear. You may be knowing polyurethane soles are very costly because in once the soles are used in PU, the soles will never get abraded. That means its abrasion resistance is very, very high. Even the polyurethane is used for making the rice rollers. That means when you want to de-husk the paddy, the rollers are made and then the de-husking of the paddy is done. It will give minimum 5 times life than the nitrile rubber. Similarly, the shoe soles will last a very long time. The upper may wear very fast, but the shoe soles will last for a long, long time. I think some of you must have experienced. Then there are some anti-slip pad, seals for hydraulic system based on mineral oil. Wherever mineral oil is used, polyurethane seals are used. Its temperature is up to 80-90 degrees centigrade. You can use. Then the butyl rubber. All the tubes what we use in cycle tires earlier, where we use more from inner tube, is from butyl rubber. Butyl rubber, as I told you, it is called as IIR, isobutylene butyl rubber. It is used in the steam hoses because this is basically, it has got a permeability to gases. Therefore, it is used in tubeless tire, waterproofing material applied as liner in tank and pond, suspension bushing for car and truck, body mounts, gas masks are used from butyl rubber. Again, it is because of the impervious to gases. Then it is used into certain extent in chewing gum. Then the next is the polysulfide. Polysulfide is basically used for oil and gasoline resistance tubing, diaphragm for gas meter. It acts as an excellent roofing material. Tarpaulin for trucks are also made in it. Then the polyacrylic rubber, which are basically acrylates, mainly used in automobile area again for making seals, bearing seals, automatic transmission seal, wall stem seal, roller, high temperature resistance coating, etc. Hypalon, which is chlorosulfonated polyethylene, as I told you, CSM, is used for making hose. Its important property is the resistance to phosphoric acid. So therefore, it is used in carrying for transportation of phosphoric acid. Then the plating shop, where the chromic acid is used, so it is resistant to chromic acid. So there also the hypalon is made use. Seating many types of wire, spark plug, goods, white side wall, tire. Because of its high ozone and weather resistance, excellent roofing material. It is used for roofing material and for truck tarpaulin also. Thank you very much. This is what from my side. If you have any questions or any clarification required, I am available. Hello. Hello.
Yes. Thank you, Mohan, for this wonderful presentation. You have taken a really very good overview of rubber industry, manufacturing process and applications.
Yeah.
I think it's a very good piece of information. That recording will be very much useful for our members.
Yeah.
I will request now participants to raise their queries.
Yeah.
We'll open the session for question and answer.
Yeah.
Please identify yourself and then ask the question.
Yeah.
Over to the audience. Mr. Vishwas Kale might have a query because he's a manufacturer and must be using rubber parts.
Yes, Mr. Vishwas.
I already put the query in the chat box. Vilas, you can read that.
Can anyone read the query in the chat box, or Vishwas, you can directly fire it?
Okay.
Yeah, you can ask me directly.
Yeah, please ask.
Do you face any issues in testing rubber and also rubber products? Because we can help you in doing that, because we make a lot of things for testing such products or such materials.
Okay.
In your presentation, I did not see anything about testing possibly. That is why I'm asking.
Yeah. I'll answer your question. See, basically the rubber industry, generally the validation is done by the customer end. Validation of the product is done by the customer. For example, I make a brake seal, for example, I will make as per their specification. Because if I want to carry out that validation test, maybe I have to invest a lot of money. So initially we make a prototype sample and give it to them for the testing.
But that means you are trusting your customers for the testing.
Yeah.
But if you get
validation of the product is generally done by the customer.
Yeah, I do agree. But as a maker, would you like to test at your end itself?
We are definitely now intending, because our company is a very small company. It's almost 10 years old.
Yeah.
So now we have planned to go for this. For example, if you consider brake seal itself, so we want to simulate the same condition what the customer is doing and carry out validation test at our end only, particularly high temperature resistant test.
I'll just suggest, based on my experience, whatever I have.
Yeah.
Instead of investing that money, there are many laboratories available all over India.
Okay.
You can get it tested from them. People like us, for example, or anyone else can act as an agent for you and get it done.
Sir, here I want to make you one thing very clear, because I have been interacting with many customers in and around. Sometimes customers are hesitating to give their test standards. So what they are telling us, you make the product as per our drawing, you submit the product, we'll test at our end. and then we'll let you know the result.
Okay, then my hands are tied anyway.
That is the problem. All customers are not very open.
Okay, okay, thank you.
Yeah.
Okay, any other query? Please shoot out, identify yourself.
Sir, my name is Anil Chaitanya.
Yeah.
I am just continuing the question which was asked by Mr. Vishwas Kaleji.
Okay.
What is the overall big company trend in testing and international trend in testing rubber at manufacturing stage?
Yeah, again, you are talking about the end rubber products, what we manufacture.
Yes, sir.
See, our role in this is basically to understand the customer's drawing and the customer's material specification and make a prototype as per the material specification and the dimension requirement. And if the customer is insisting that we must validate the rubber product, then they have to share their standards. For example, when you test the Japanese car, they have a JIS standard, or when you test other automobile industries, they have the standard for testing, say, brake seal, or for example, even a small O-ring. If they give us, then they require, then maybe the rubber product manufacturer is happy to put up this thing, because I will also know what is the our quality standard, and maybe I will have benchmark with their samples also. That will help us in a great extent. But unfortunately, again, I am repeating, customers are not so open.
Okay.
They only tell your product should meet our benchmarking sample. Only after the prototype, if it is okay, they tell us it is okay. Now you go for multi-cavity, and then we go for multi-cavity product mold.
May I make a comment?
Thank you, sir.
May I make a comment?
Please go ahead.
No.
Yes or no?
Yeah, please.
See, you just referred the standard. We are already working with many companies, and they give us a standard against which standard they should be checked.
Okay.
Currently, I am also on the committee of Bureau of Indian Standards, so I am also
Okay.
very much aware about the standards.
Okay.
So if your customer tells you this should be tested as per standard XYZ,
Okay.
that can be carried out. I don't see any problem in that.
Some of the here the problem is if I want to develop this test rigs, for example, number one is the standard we can procure if you tell them, but the small companies cannot afford to put up such big rigs, no. Because today, if I want to test the seal, my minimum cost will be around 25 to 30 lakhs rupees.
No, you can get it tested from different laboratories. That I'm again trying to help you.
I'll be happy. Later on, I will interact with you.
I am connected with a lot of laboratories which can test again different standards. That is,
No, the standards are available.
Trying to share whatever little knowledge I have with you.
Yeah, standards are available. But laboratory, if you have any list, please share me the list. Maybe we'll approach for validation.
Sir, that is what I am trying to share with you. That data is available, laboratories are there. I am connected with them. I am on the Bureau of Indian Standards. So please do take my help if you want.
No, that's what I'm telling, sir. That's what I'm telling. I will get all your details from Vilasji. Then I will contact you. There is no problem.
Yeah. So I will share.
I'm just trying to help you, nothing else.
I'll be happy. I'll be happy if I start interacting with you.
Yeah, I will share in numbers.
Please, Vilas.
Contact numbers with each other.
Sure.
About Mr. Mohan Deshpande, I already shared his business card. Anyway, any more questions? Last questions we will take now. There are no queries. I think Makaran Vaidya wanted to say something.
Yeah. Yes, Makaranji.
Actually, I have shared on the this thing chat box. Okay. Still, I will call you actually, and I was expecting some insight on the natural rubber as its physical and physical properties as well as its utility in the present times. I mean to say, I was expecting that also.
Natural rubber utilization, you mean to say?
As well as some insight on its physical properties, some insight on the wisdom behind that natural resource which is natural rubber, I mean to say, because it has got its own beauty and its own utility.
No, I do agree with you. Natural rubber is definitely still a major rubber used in tire industry, because 80% of the rubber used today is for the tire industry. And even some of the dynamic application like anti-vibration mounts and all those things are still natural rubber is required because of its high physical properties and good abrasion resistance.
Actually, I will tell you, it is a tire and all that is a known thing, but very specifically, I got only half a minute to talk. But it looks like, but I could say I got one application I saw where the natural rubber withstand, and every elastomer, including in engineering, we feel like silicon rubber is a boon. Silicon rubber is the beauty of everything, but that did not turn out to be. In that application, I found natural rubber is the best fit. And natural rubber solved my issue, my problem. And silicon rubber just got burnt, just got vanished from that O-ring. O-ring, it was a packing, some flange packing was there. So that vanished because of sodium hypochlorite, and natural rubber withstood that place. So that shows that natural rubber has got more wisdom and more physical properties than any other man-made things. That's what my feelings were.
No, sir. What is important is, as far as the heat resistance is concerned, natural rubber can withstand maximum up to 70-80 degrees centigrade. So wherever O-ring has got issue, maybe because of that medium, whatever the hypochlorite you are telling, no. So silicon may not be resistant to that particular chemical. It is not because of the heat resistance property. It is because of the chemical what you are using.
I understood. I just elaborated and expanded the wisdom of the natural things available.
No, I fully agree with you. But it depends on the application what you are exactly using. Because if you use, for example, nitrile rubber is also a very good rubber. If you use it in brake fluid, it will next day it will degrade, because the brake fluid is a medium where either SBR or EPDM need to be used. That's all. So any wrong usage of the medium and rubber can create confusion. I understand from that.
Yeah, I think that's a good conclusion, I should say. I must thank Mr. Mohan Deshpande for this wonderful presentation and a lot of intelligent questions and interactions generated after that. So that is a success of the presentation. Of course, it was overall issue, but probably we can take up some typical issue of this rubber industry, because this is the first time we are exposed to the rubber industry.